This is the day 3, I'm sorry, it's not day 3, it's actually day 2, part 3. So I have a day 2 A, B, and C 3-part lesson. Yeah. So we're going to look at graphing logs, and I want you to recall that in 2B we looked at identifying the parent function. So in each of these situations we decided, okay, 6 to the y equals x. That's my parent function. This is a transformation happening, right? A right or left shift. And this is another transformation taking us down 5, right? So here we have 5 to the y equals x is our parent function. -1 is taking us to the right 1. +3 is taking us up 3. So really, we already know how to graph these. You know how to graph 5 to the x equals y, but now we're going to graph 5 to the y equals x. So let's go ahead and check it out. Alright, I have a couple steps written for you. We're going to rewrite the parent function in exponential form. So we would write 2 to the y equals x. This +1 is outside. Let's see. So we're going to write 2 to the y equals x. So in the past, we plugged in values for the x and figured out what the y would be. But our x used to be up here. But because we're in this form, this is a logarithm form, because we're in, it's exponential form, but because the y is in the exponent, it would be easier to plug in values for the y and find what we get for the x. So we're going to plug in the same values we used for x, right? Because logs and exponential functions are inverses of each other, our x's and y values kind of just flip-flop. So if we plug in -2, -1, 0, 1, 2 for our y's, we will get something very similar, or something we've seen before for our x values. So we plug in 2 to the -2, right? That negative in the exponent, we're getting experts at this. 2 to the -2 is 1/4. So we get 1/4, 1/2, 1, 2, 4. I'm going to write that in. 1/4, 1/2, 1, 2, 4. Okay, so we can go ahead and plot these points. Let's see. So we've got, when x is 1/4, we're about right here, and we go to -2. X is 1/2, go to -1. And x is 1, go to 0, 2, 1, and 4, 2. Alright, so I'm going to go graph this. Alright, so our graph should look something like this. Now I also drew the asymptote right here. So as our x's get more and more close to 0, we approach 0, we're approaching the asymptote. And so we can set up our domain and our range. Now, if you remember, since logarithms and exponents are so closely related, before, the domain was always all real numbers when we had exponential, because it kept going all the way this way and all the way that way. But now, since x and y have switched to the inverse, now we have the range is all real numbers. All the y's keep going down, 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 and all the y, we keep going up, so we're using all values of y. So the range is all real numbers. And the domain is all x values greater than 0. Our asymptote would be x equals 0. Alright. So notice there's a difference. We used to have, our asymptote was a y equals 0, so a horizontal asymptote. Now we have a vertical asymptote, and it's x equals 0. Domain, all x's greater than 0. So you really need to be careful and consider, oh my gosh, I just realized something. I graphed the parent function to the y equals x, but I forgot about this +1. Alright, So we want to, let's go back and look at that. This plus 1 is telling us we're moving up 1. So I know it's a plus k because if it were an h, it would be inside a set of parentheses, and I don't see any parentheses there. So this is my plus k, so we're shifting up 1, and up and down movement affects my y, so I'm going to have y plus 1. Right here. Alright, so let's find those values. Alright, so the graph would look something like this. So I just took this blue graph, copied it, and pasted it, shifted everything up 1 unit. So if you notice, my domain, my asymptote, nothing changed over here. I still have all real numbers for my range. So shifting up and down, this k no longer affects my asymptote. Whereas when we had exponential functions, if we had plus or minus k, that affected our horizontal asymptote. It shifted our asymptote up or down. So now, what can you predict is going to affect our asymptote? If you said the h, then you are correct. Yes, the h is going to shift us right and left, and now that our asymptote is vertical, it can shift right or left, so the h is going to affect it. Alright, let's try another one. Oops. Okay. So we have log base 3 of x minus 1 equals y. Alright, so we want to set up a table of values for the parent function. And the parent function here is 3 to the y equals x. So again, instead of plugging in -2, -1, 0, 1, 2 into my x values, I'm plugging them into my y values. 3 to those, each of those will give me 1/9, 1/3, 1, 3, 9 as my x values. So notice this minus 1 is now in, it's my h value, right? It's my right or left shift. And this is shifting right 1. So again, if it's on the inside, so we have parentheses on the inside, we're going to put over here x plus 1. And we're going to add 1 to each of these values. So x plus 1. And then we have 1 and 1/9. 1 and 1/9. I'll hit pause and do it. So we get over here 1 and 1/9, 1 and 1/3, 2, 4, 9. Just adding 1 to each of these values. Yeah. So let's look at the next slide. It actually has the graph. We want to check out our asymptote. Is it, oh, I changed it. Okay, hold on. Sorry. There were a couple errors on that, so I fixed them up for you. Sorry. So we started with our parent function. We got our values ready. We plugged in values for the y and figured out the x values. And we did the opposite operation here. This was our h shifting right or left. We went plus 1 for our x values. We graphed these values, and our asymptote is now at x equals 1. So notice, now our asymptote is determined by the h, but the opposite of h. Right? So here, domain x greater than 1, all real numbers is the range, and x equals 1 is my asymptote. Alright. So here we have two different transformations. I want you to pause for a second, get your parent function set up, and then get that table ready. And see if we get the same values for the table. Alright, hold on. Alright, go ahead and hit pause. Try it, get it set up, and then hit play. Alright, so your table value should look something like this. We have 3.25, 3.5, 4, 5, and 7. Now, I did this a little differently last year, but I just have plus 3, so I added 3 to all the x's. Notice it was x minus 3. We had to do the opposite, so we added 3 to the x's. Plus 4 to the y's, we're going up 4. We add 4 to all our y values. And notice our asymptote shifted 3 places to the right. So our asymptote is now at x equals 3. The domain is all x's greater than 3, and our range is all real numbers. All x's greater than 3 and all. Okay. That would be that problem. So that was just a brief overview of how we're going to be graphing logs. Thanks for watching.